Hi everyone, welcome back to Jom Study the YouTube channel. Today we are diving into an exciting part of chemistry that plays a huge role in everyday life. Organic chemistry, whether it is the fuel in your car, the medicine you take, or even the food you eat. Organic chemistry is all around us. So let's break it down in a way that easy to understand, especially if you are studying for A levels. Without further ado, let's get started. What is organic chemistry? Organic chemistry is the study of compound mainly made of carbon and hydrogen, often include elements like oxygen, nitrogen, sulfur, and halogens. Example, methane, CH4, ethanol, C2H5OH. Differences between general chemistry and organic chemistry is general chemistry is the study all types of element and compounds, example salt, metals, acids. Meanwhile, organic chemistry is more focuses only on carbon-based compound. Let's look into the organic chemistry molecular formula, which is show number and types of atom in a molecule. Example, ethanol is C2H6O. And the structural formula shows how atoms are connected in a molecule. Example, ethanol, CH3, CH2, and OH. Let's look into the organic chemistry in terms of the display formula. We show a diagram for every atom and bond clearly. You can see in this slide, this is how the display formula look like. And for skeletal formula, for butane, it's this display C4H10. And for names and functional group, organic chemistry, functional groups are part of molecule that react. And common group for organic chemistry is OH represent alcohol, COOH is referred to carboxylic acid, NH2 is amine, CHO is aldehyde. Example, we have ethanoic acid where CH3, COOH, where ethanoic acid has COOH. For the hydrocarbon change made of only carbon and hydrogen, and it can be in a form of straight, branch, or ring, cyclic. And let's look into the alkanes. Alkane has single bond, saturated hydrocarbon. The formula is CnH2 and plus 2. An example, methane, which is we have CH4, and ethane C2H6. And reactions is combustion. And for the organic chemistry in terms of arene, arene is aromatic hydrocarbon with benzene rings, stable ring of 6 carbon atom. Example, benzene, which is C6H6. And other functional group, we have a display here for the organic chemistry is alcohol, which is OH indicator. And carboxylic acid is COOH. And ketone is C equal to O within change. Aldehyde is CHO at the end. Ester is COO. Amine is NH2. And each group give unique chemical properties. And for the organic reactions, we have example here about fission of bond, where bond can break into ways, is homolytic which is represent each atom keep one electron to form free radicals. And we have heterolytic is whereby one atom get both electron to form an ions. And second, we have free radical reactions, which is involve unpaired electron. Example, CH4 plus Cl2, and to produce CH3Cl plus HCl in the presence of UV light. And thirdly, we have nucleophilics and electrophilics reactions, where nucleophiles is where electron rich attack positive centers. And we have example here is OH and NH3. And then we have the electrophilics. Example is H plus NBr2. Electrophilics is where the status is electron poor and is attack negative center. Then other type of reactions with regards to organic chemistry is addition, substitution, elimination, hydrolysis, oxidation, and reduction. For additions is where atom added to double, triple bond, and substitution is one atom or group replaced by another. Eliminations is whereby atom group removed to form a double bond. And in the process of hydrolysis reaction is where water breaks a molecule. Oxidation is a process where gain of oxygen or loss of hydrogen. And finally, reductions is where the process is gain of hydrogen or loss of oxygen. Shape of molecule that we have, the first example is ethane. The ethane structure is a single bond between two carbon atoms and each bonded to 3 hydrogen atoms, C2H6. And ethane is a type of alkane which is saturated hydrocarbon. And each hydrogen atom has one s orbital containing one electron, and each carbon atom uses its sp3 hybrid orbital, which is formed by mixing 1 to s and 3 to p orbitals to bond. And each carbon atom forms 3 CH bond, meaning by overlapping its sp3 orbital with hydrogen, 1s orbital. And second, they have one CC bond, which is called a sigma or a bond, by overlapping one of its sp3 orbital with sp3 orbital from the other carbon atom. And this overlap create molecular orbital where the hydrogen nuclei are embedded, forming stable bond. The CC sigma bond allows free rotation around the bond axis, meaning the two CH3 methyl group at each end can rotate freely relative to each other. There is no rigid structure preventing this rotation, and ethane is made of 2 carbon atoms and 6 hydrogen atoms, and each hydrogen atom has 1 electron in 1s orbital, and each carbon atom share electron using sp3 orbital, a type of bonding orbital. And bond in ethane can be seen in 5 types. First, each carbon form 3 CH bond with hydrogen atom. Second, the 2 carbon atoms are joined by a single CC bond, which is sigma bond. Third, the CH bond are made by overlapping a carbon sp3 orbital with hydrogen 1s orbital. Fourth, the CC bond is made by overlapping one sp3 orbital from each carbon. And fifth, this CC bond allow the 2 ends of the molecule to rotate freely around the bond, so the 2 CH3 methyl group on either end can spin without breaking the bond. Then let's look into the shape of molecule ethene. Ethene, the molecular structure is C2H4, and the structure is a double bond between two carbon atoms, each bonded to two hydrogen atoms. And the type of ethene is alkene unsaturated hydrocarbon, H2C equals to CH2. Carbon hybridization, each carbon atom in ethene undergoes sp2 hybridization, meaning that 3 of the 4 valence electrons in each carbon mix to form 3 sp2 orbitals. The remaining 1 electron stay in unhybridized 2p orbital. And then sigma bond, and each carbon uses 2 sp2 orbital to form sigma bond with 2 hydrogen atoms, 1 bond per H, and the third sp2 orbital from each carbon overlap with each other, forming a CC sigma bond. Then we have pi bond. The unhybridized 2p orbital on each carbon overlap sideways to form a pi bond above and below the sigma bond. And this pi bond form the second bond in the CC double bond. The effect of the pi bond is the pi bond prevent rotation around the double bond, and this is because ethene has a rigid planar structure. Then the third molecule is benzene. The molecule structures for benzene is C6H6, which is a ring of 6 carbon atoms with alternating double bond, often represented as a circle inside hexagon to show resonance, and the type is aromatic hydrocarbon. Each carbon atom is bonded in a similar way to show how carbon atom bonded in ethene, a double bonded carbon molecule. And each carbon atom in benzene uses 3 sp2 hybrid orbitals, 1 bond with a hydrogen atom, 2 bond with the carbon atom next to it in the ring, and each carbon also has 1 unhybridized 2p orbital, and these 2p orbital overlap with each other around the rings. This overlap form a shared cloud of electrons called a pi electron cloud that sits above and below the flat rings of the molecule. And this electron cloud gives benzene its special stability and unique chemical properties. And these are the sample diagram which already explain about the shape of the molecule for benzene. Then we have isomerism. Isomerisms are compounds that have the same molecular formula, same chemical composition, but different structural formula. Structural isomerism can be divided into several types. First, change, position, functional, then followed by geometrical, and finally optical. Structure isomerism that refer to change. The change arises due to branching of carbon change. C4H10 can be straight form or branch form. So these are the molecular formula. And for the structural isomerism refer to position is where carbon change is fixed, but the position of substituent group can vary. Changing the position of the group affect easily it reacts its physical property like boiling point. Third, we have functional group isomerism. Functional group isomerism refer to the type of functional group within a molecule determine the kinds of chemical reaction it can undergo. Example, the molecular formula C3H6O can represent three different compounds and each with a different functional group and therefore distinct chemical properties. So we have propanane, propanone, and 2-propane-1-OL. These are the three different compounds that refer to functional group isomerism. Fourth, we have geometrical or so-called cis-trans isomerism. Occurs in compound with a restricted rotation, like double bond. Atoms are arranged differently in space. Cis-trans isomerism. Cis refer to the same group of the same side. Trans refer to the same group on opposite sides. And dichloroethene is referred to no geometrical isomerism, both Cl on same carbon. So these are the diagram that's shown below. And the fifth, we have optical isomerism. Optical isomerism refer to when compound has a chiral center, carbon with 4 different groups. Optical isomer are minor images, but not superimposable. An example given here is aminopropionate acid, and where has a chiral carbon connected to H2, NH2, and COOH and CH3. So where exists L-align and D-align, optical isomer. So these are the examples that's shown for optical isomerism. That's all that we have for you today. Hope please on your notifications so that you can get latest update, and wish you all the best in your studies and upcoming examination. Thank you very much.